Okay, let's get some more examples in here. Another quick example, 3t squared plus 25t plus 8. Think of two numbers that multiply to give you the product of the outside numbers, right? 3 times 8 is 24. Can you think of two numbers that multiply to give you 24, but add up to 25? Well, 24 and 1 seem to make sense. So if you walk through the steps, like the tutor mode shows, we could say 24 and 1 work for these combinations. Split 25t up as 24t and 1t. And then when you see things, see it written this way, and you want to be writing this down yourself on paper as you go, that you'd have 3t squared plus 24t plus t plus 8 is your new rewritten problem. You'd group the first two, you group the second two, and pulling out what's common from the first two terms, I've got a 3 and a t. That would be a greatest common factor for these two terms. When you divide that out, you're left with a t and a plus 8. And for the second one, like a previous example that we had, the greatest common factor is 1. So that's all we can write. T plus 8 remains inside. So with the common factor of t plus 8, we can say, using parentheses, if I can get it to work right here, t plus 8 is a common binomial, comes out front. After you divide that away, 3t plus 1 is left in the parentheses. Okay, t plus 8 times 3t plus 1. Alright, yes, we'd like to continue practicing. Alright, I was hoping to get to an example like this. These look a little bit different than what we've talked about so far. When I look at these three terms, what I notice is that you have, it doesn't fit that standard trinomial second power, first power, constant type pattern that they've been showing to you. This actually has multiple variables, has some higher powers like a power 3, then a power 2, then a power 1 for the q. So what we want to do is look for the greatest common factor first from all of this, and then we're going to proceed like we have been with the stuff that would be remaining inside the parentheses. So we'll see what tutor mode has to say for the steps. They want us to determine whether this can be factored. I'm looking at some greatest common factors, some common factors already in these terms. Definitely factorable. Okay, so then they're kind of helping you out a little bit actually by showing you what goes here. But you would kind of arrive at that on your own by looking at the regular numbers and saying, well, 7 is the greatest common factor. Q's, q to the third, q squared, q, they all have a q in common. Y, and y, they all have a y in common. So if you were to divide this by 7qy, you'd get 4q squared. If you were to divide this by 7qy, you just have q. If you divide this by 7qy, you just have 6. So that's where this came from over here. But we'll have 7qy times in parentheses this stuff. Okay? So the stuff in the parentheses, they say, is this trinomial factorable? Well, to know that whether it's factorable or not, we'd have to think about the number combinations like we've talked about. 4 times 6, the outside numbers, is 24. Can you think of anything that would be multiplied to give you positive 24 and add up to 1? And I'm thinking, because it's plus plus, the only things we can do are combinations of positive numbers. There's no way we're going to add 1 and 24, 2 and 12, 3 and 8, 4 and 6. All these combinations that would multiply to give you 24, none of them are going to add up to 1, which is the number that would be in front of q. So this is not factorable. but sometimes it would be, and you would proceed like we have on previous examples to factor by grouping by using the combination that would work. So they basically say, hey, what you had on the previous step is your final answer. You couldn't factor it any further. Okay, another example here. We'll try to get through this with the time we've got. I see that there's negatives in everything here, but in particular, the highest powered term has a negative in front of it. So if the highest powered term has a negative, I'm going to be pulling out a negative in addition to anything that's common. So if we answer the same question, definitely factorable. And they want us to think about what to pull out. Notice everything is positive in here, so yeah, I'm definitely pulling out a negative value. And in addition to that, greatest common factor between these, 12, 24, 28. It's looking like with the 12 doesn't work with this guy. Other factors of 12, 6 would not work with 28. 4 would work with all these guys. So you can kind of talk through based on the factors of the smallest number and see if they fit into these other numbers. Minus 4, c squared. You've got c times c is common with everything. And then also have a v in common. So if you divided this stuff away from each one of these guys, the stuff in the parentheses is what you'd have left. And then this is like the last question. Is this trinomial factorable? 6 times 7 is 42. You're not going to find two numbers that multiply to give you positive 42 and add up to positive 3. Maybe if there was a negative and a positive, but it's just positive, positive. So they're kind of repeating their problem type in this example as compared to the previous. Let's see, this one here, 2r squared plus 7r plus 6. Is this going to be factorable or not? Well, if I said 2 times 6 is 12, and I tried to start thinking of numbers that would multiply to give me 12, but add up to 7, 1 and 12, 2 and 6, 3 and 4, those are all pairs that multiply to give you 12. 3 and 4 would add up to 7. So this is going to be factorable. Remember how it works? You can say, okay, 3 and 4 is the combination that works. So if I use 3 and 4, I'm saying 3r plus 4r. And based on splitting that apart, we can factor each pair of 2 by the greatest common factor. R comes out front of the first two. 2r plus 3 is left inside. 2 is the greatest common from the second pair. 2r plus 3 is what's left after you divide that away. So if we look at this, 2r plus 3 is what's common. After that's divided away from each term, r plus 2 is what's left in the other factor.